All right, so real quickly, we've been talking about all the math that we need to go about graphing and doing whatever it takes to do a linear programming problem. The inequalities, the shading, and then I think I mentioned yesterday that the shaded part that you've been getting when you've been shading these problems, that in linear programming, these formulas or these equations are going to mean something. They're going to come from something that you read in a problem. And the area that you shade, we call that the feasible region. And the feasible, like the word feasible, means what's possible. So anything you shade, any point that lies in there is going to represent a pot. Like if you were running a business and you were trying to figure out how many things you were supposed to make of each kind, or how many tickets you're supposed to sell, or how many acres of land you're supposed to plant with each kind of crop. Whatever it is you're talking about, this shaded region is going to represent the points or the opportunities that you have to be successful. But you just don't want to be successful. I mean, you can run a business and not lose money and still not make a great living. You usually want to maximize your profit or minimize your cost or whatever it is you're talking about. So in this feasible region that you're going to have, everybody with me? In this feasible region that you're going to have, there are certain points that are going to maximize or minimize these revenues or costs or whatever it is we're talking about for each particular problem. And those points that are going to be your best opportunities are going to lie along the edges, okay? Specifically at the coordinates of where these lines intersect. So if a line intersected here, that coordinate, or if it intersected here, that coordinate, those are the ones we're going to be looking and testing to see which gives you the absolute best possibility. Are you with me? And also, sometimes along this line, you're going to have equal opportunity as well. But if you just test the coordinates of the intersections where the lines intersect, that's going to be at least give you your best opportunity. And sometimes there's 4 points to check, sometimes there's 5, sometimes there's 3, whatever. So that's the whole idea of what we're doing. The thing you have to work at, the challenge you're going to have is, can you come up with these equations that you need to be able to get this region? All right? And I gave you some hints. The first thing I said was, as you're reading through here, as you're reading through any problem, identify what the question is asking. Because the question that's being asked is going to define your variables. Now, there's one exception. And it's not even an exception, you can always do it this way. But there's one problem in here where the math is just a little easier if you don't do that. Like if the question's saying how many acres of each kind, and you'll see this problem, we're talking about planting acreage of corn and wheat or something like that. And on that particular problem, I'll show you how to do it based on my suggestions on this, on page 13 where it says these guidelines. We're going to do it based on the guidelines. And then I'm going to ask you, I'm basically going to ask you, does anybody see another way you might go about doing it? And sometimes when you veer off these guidelines, it might be a little easier to come up with your equations. Your equations don't become as tricky to find. But as a general rule, these guidelines are going to hold really well for you if you just follow them, if you have any issues with these kinds of problems. Okay, so the first thing I said was, usually what we're trying to do is either maximize profit, minimize cost, maximize revenue, whatever. Identify that equation first. And usually there are two things going on because it's an X and a Y coordinate plane, so there's two variables in play. And those two variables are going to create a two-variable function, which we haven't, actually a three-variable function. It's going to be like revenue equals, and you're going to have an X and a Y in the actual function, which I know I'm using function loosely here, not like a real function that passes the vertical line test or whatever, but a unique expression that relates how I can maximize profit by adjusting these X's and Y's. So the first thing, and we're going to do this and it's not a big deal, that's probably the easiest thing to find. But once you identify what we're actually trying to do, go in there and look. There's going to be something about it that states whether you're maximizing or minimizing something. That's what I want to identify, and I want to come up with that equation. That's the second thing that we're doing right here, is identifying that equation. And once you identify it and write it out, all that information that gave you that equation, cross it out so you don't accidentally use it again. It's a real temptation to use this stuff in multiple equations because it can be confusing. All right, so once you identify that and write it down, like this is an example. it says the attendant charges $4 per car and $6 per truck, right? So I'm trying to make money, right, by charging people. I charge a little bit more for a truck because it takes maybe a little bit more space. So the revenue that I'm going to earn, the money I'm going to make, is $4 for each X, if X stood for car, and $6 for each Y. So you need to look at the equation, read that, and as soon as you have it, go ahead and draw a line through the 6 and the 4 so you don't accidentally make another inequality out of that and start messing up your problem. Okay? So identify the variables, identify whether it's the profit, the revenue, the cost. You'll understand when you start reading this. And then the third thing is, I have to come up with all the lines that are going to give me these shaded situations so I can get that feasible region. That's the part that might be the trickiest for some of you. Some of these equations are going to be pretty easy to find, as you'll see. Some of them are slightly trickier. But the thing that's going to be a hint to you is these are shaded situations. And if they're shaded, that suggests an inequality. So look for things like at least. When you see the word at least, that suggests less than. That's going to drive you towards an inequality. If you see stuff like, hey, I can spend no more than $3,000 on this. Well, if I can spend no more than $3,000, that means I have to spend less than or equal to $3,000. That's an inequality, right? If I have if I'm a business and I have certain employees working for me, well, they can't work 700 hours a week, right? Let's just say I cap a certain employee's number of hours at 60 hours, and I have 5 employees. And that gives me 300 hours available, right? I don't want to work them more than that because then their quality of life goes down, they start looking for other jobs, maybe they get miserable. And granted, plenty of people work more than 60 hours a week. Doesn't mean they're always happy, but anyway, my point is if that's all I have, then the number of hours at my disposal is less than that. So I'm going to write these things down and then look to see how I can manipulate X and Y so that it matches up with pens or costs or hours. And you'll see what I'm talking about in a second. All right, so look for these inequalities and then remember, whatever I'm talking about, it's a real world situation. If I'm talking about cars and trucks, can I have -4 cars? No, so the number of cars is positive or 0. Can I have -6 trucks? No, I can have 0 trucks, but not negative. So that means that my variables will always be positive on these real world problems. Well, if X is always positive, that puts me where? If I say X is greater than 0, vertical line shaded that way. If I say Y is greater than 0, number of trucks is greater than 0, horizontal line shaded up. Well, where is that overlap when I shade to the right and up? First quadrant. And that's why I've always given you pictures. When you see this first one, you'll see I'm only giving you the first quadrant. So when we start looking through this, kind of think this way. Hopefully this will be not too bad for you. It is going to require you to know how to solve a system, know how to shade well, how to be careful, how to plot intercepts. But all that stuff we've been talking about, hopefully you'll be in good shape with this. All right? And then I said look for places in the equation where units match the units. Bottom line is, if X stands for trucks and Y stands for cars, and I have X plus Y equals or less than or equal to 3,000, doesn't make a lot of sense. Vehicle plus vehicle equals cost. There would have to be something else going on in there. And when I show you what I'm talking about, you'll go, oh, that does make sense. And it's kind of a stoichiometry issue or a unit issue. But making sure your units on the left match the units on the right is important. And sometimes that's really straightforward, sometimes it's not. But again, we'll work through these. I think you'll be fine. All right? And then the last thing is, even though I know it's in the first quadrant, if I ask you for the equations that represent these inequalities, these are understood. Make sure you write them. Unless there's some other unit that trumps it. Like what if I said, what if X stood for trucks? And you're like, well, I know that I have at least 0 or more trucks. But what if in the problem I go, hey guys, you gotta have at least 10 trucks. Well, at least 10 trucks means that X is what? Greater than or equal to 10. Well, obviously that trumps greater than or equal to 0, so you wouldn't have to put that, just put X greater than or equal to 10. But anyway, you'll see it. The more we do these, the better off you'll be. I'm hoping I can do, well, we've got 4 of these for classwork. I think there's 4 of them for homework. And after you do 8 of these, you'll be good and sick and tired of them. But I think you'll be in pretty good shape, even just doing these 4. All right? So let's check out this first one and see what we can do. So the first one's talking about maximum profit, okay? And I may or may not say that on a test, but I'm just trying to make it painfully obvious. So it says, a merchant plans to sell 2 models of compact disc players. This is kind of an old problem, clearly, since we really don't sell a whole lot of compact disc players these days. It's mostly, streaming stuff. So I'm selling 2 kinds of compact disc players. One of them, and I'm sorry, it said I'm buying them from a wholesaler at costs of $200 and $400, $250 and $400. So basically, the guy's going in there and he's going to some manufacturer and he's paying $250 and $400, but he plans to sell them at an increased price. Okay, so the $250 model, which is the cheaper version, is going to yield a profit of $45, which is not that great, but evidently he's going to be selling them for $295, right? And the $400 model is going to yield a profit of $50. So evidently he'll be selling, his cost was $400, but he'll be selling them for $450. And it says the merchant estimates that the total monthly demand, so the people who want to buy these things, will not exceed $250. Maybe he's done a little market survey and he's in a certain part of town and there's just not as much demand. He's not going to be getting any more than 250 purchases monthly. And then it says the merchant doesn't want to invest more than 70 grand in inventory. So he's only got so much money in his bank account. He doesn't want to put any more than that, or maybe he just doesn't want to risk any more than that on this business to buy up inventory to sell for these products. Find the number of units of each model. So find out the number of that, the number of these, and the number of those that should be stocked in order to maximize profit. Okay? So I got a lot of stuff going on in here. And at first glance, you might look at this problem and go, ooh, crud, I don't even know where to even start on this. So let's slow down. What's the first thing I asked you to do? Identify what's the problem, what the question's being asked. So the question is, find the number of units of each model. So since I like X and Y, what do you want to make X? So what about the 250 model? How much it costs, how many there are, how many are... The number of them, right? So the number of each. So X is going to be the number of $250 CD players. CD, yeah, compact disc players. So the key is the number of, and then Y would be the number of $400 players. Now, if you don't write that, I don't care. But I'm just saying, if you struggle at all with these, a lot of times the struggle is on identifying what the question is. It's worth doing that, at least mentally. But I'm going to write that down on probably all of my keys, so you'll see that there. Now, what's the second thing I told you to do if you're struggling with this? On your little guidelines. So identify whether it's profit, cost, revenue. This was saying what? I'm maximizing profit. By the way, do y'all know the difference between profit and revenue? If you don't, I'm seeing a couple of yeses, but if you don't, profit is not the same as revenue sometimes. Like if you are a tutor and you're tutoring on the side, there's not a lot of money you have to invest necessarily in your tutoring business, right? I mean, you just go out there and help somebody. I mean, I guess you could talk about a pencil, but you can probably, and a piece of paper, but you can probably find that around your parents' house for free, right? So there's not a lot of infrastructure you have to build out unless you're renting space and really making a huge business of it. So all the money you bring in, that's your revenue. The profit would be how much you bring in minus your cost. So if you did spend some money, like on pencils or maybe a projector or maybe a whiteboard, you would subtract out those costs from your total revenue that you brought in. That would be your profit. This says, I want to maximize profit, okay? So profit's not the revenue. Revenue would be, I'm selling these for $295, I'm selling them for $450. But profit is the money I'm making off the sale. And what was I making off the sale of this? And this is how I write a 2 variable, technically 3, because there's profit and there's X and there's Y. But I'm not just going to write f of X, it's like f of X comma Y. What am I making when I sell the $250 CD player? I'm making $45. So technically it's a $295 CD player, but I'm talking about the cost of those. Okay? So I'm referencing those directly. So my profit is I'm making $45 for each what? For each X that I sell, and I'm making $50 for each Y that I sell. And then I'm going to say, you know what, I've already used that 40 and that 50, and the 45 and the 50. I'm going to draw a line through that so I don't accidentally work them into some other problem. We good so far? Now the next thing is I need to identify I'm not going to be graphing this. This is what I'm going to use to actually solve this problem in the end. So that's not going to be graphed. Actually, you could graph it, but it would be this weird sliding graph. It's kind of hard to visualize, and I may or may not talk about that. But how do I figure out the next step? The next step was identify the lines, the inequalities that I'm going to have on this thing. I need to look for what? What does the guideline say when you forget stuff? Look for what? Yeah, look for situations that suggest greater than or less than. So as I'm looking through here, blah, 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 the merchant estimates that the total monthly demand will not exceed 250. What does that mean? Can't go over, but what does that mean mathematically?
X plus Y is...
Okay, you're going way ahead, but which is good, but just tell me, what does that part mean? Will not exceed 250 means what? Less than or equal to, right? Because it could be equal to without exceeding 250, and then I put units, and then Sam said X plus Y is less than or equal to 250. That's great, because X is a what? It's a unit. It's an actual CD player. So the number of these plus the number of these will not exceed, but could be equal to that many. And the units match up. Are you following me? Okay, so that takes care of will not exceed 250. Then it says the merchant does not want to invest more than $70,000. What does not want to invest more than $70,000 mean? Less than or equal to 70,000. Now that's money, right? The units are in dollars. So does X plus Y make sense here? Units, dollars? No. But if I'm buying these things up in my inventory, what will make those be dollars? Putting a 250 with the X, because that's how much I'm spending on those, and putting a 400 on the Y. Now if you're wondering, how does that make the units? This is what? $250 per unit, right? I'm spending $250 per unit times the number of units, and the units cancel and it gives me dollars. And dollars plus dollars is dollars. And that's what I mean when I'm talking about if you're having any trouble, make sure your units match when you're looking at these and adjust them if they don't. Okay? Because sometimes it kind of seems like they'll match, but they really are not. So that took care of this. Does not want to invest more. And then it says, is that it? Do you see anything else that talks about inequalities? I don't see anything, but I know something. Can't be a negative, so what does that mean? That's right. X and Y have to be greater than or equal to 0. And that's probably the more common thing that people forget. It's not going to get you killed on a test. You probably get dotted when you forget them. But that's what X greater than 0 is the vertical line going this way. Y greater than 0 is the horizontal line going up. And that's why I went ahead and just gave you that graph. So I want to graph these, shade, so that I find my feasible region. I want to find the intersection points, because those are going to give me the best possible scenario for success here. And then I want to take those points and plug them in my profit equation and see which one gives me the most profit. And that's my goal on a linear programming model. So how can I graph X plus Y equals 250? Now, first of all, it looks like this is labeled 10 to 10. Is that really going to work for you here? No. So how are you going to do the units? And it's your choice. You do them however you want them. How do you want to label these little digits here? $25, $50, You know what, before I do that, and that is, it would be, actually it wouldn't quite fit it in if you did 25 on each one. What I'm gonna do is do a real quick check to figure out how I'm gonna label these by finding the intersections of these. And if I have the intersections, then I'm gonna know, I'm gonna need to be able to draw these so that they fit in there. So it might be a good idea to find your X and Y intercepts real quickly and then adjust your graph accordingly. So what would be the X and Y intercepts of this thing? 250 and 250, that's pretty easy. What would be the X and Y intercepts of this thing? I'm gonna put X intercept, Y intercept. So the X intercept would be when what? Y is 0. So what's your X intercept on this? 70,000 divided by 250, and 70,000 divided by 250 is 280. So I'm going to need to go to 280 out here, and then what's your y-intercept? Right, 175. So I'm going to have to go up to 175 here. So 25 here would be great. And you can do it any way you want. I'm a bigger fan of doing the same thing on both, but that's your call. I don't know why I'm a bigger fan, doesn't mean that makes sense. But what would be a good way to write these tick marks to make sure you could get 280 and 175 in there? You could go by 50s, 30s. I like to stretch my graph out, make it as big as possible, use as much of the graph as I possibly can. So if I went by 30s, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300. If I did that, 300, 270, I can probably get all these in there pretty nicely. So you said 270, 240. So you said this one had X and Y intercepts of 250. So I'm going to go up to 250, which is a little bit bigger than this. And I'm going to go to 250, which is a little bit bigger than that. And I'm going to do the best I can at drawing this line. But it's not super important that it's perfect because you're going to be using algebra to solve where they cross. And then this one, the x-intercept was 280. 280 is a little bit bigger than that. And 175, a little bit smaller than that. And you're going to draw that line like this. And then x greater than 0, again, would have been this vertical line. And y greater than 0 would have been this horizontal line. And where would I be shading? These x and y's greater than, to the right and up. These other ones, y less than, and then there's positives here, so you would have been changing the sign, right? Right? If you subtracted x and subtracted 250x and divided, it would still be y less. So these are shading down. So when you do all that shading, where do you end up here? Right in here. This is your feasible region. Now in that feasible region, you have 4 points. What are they? Some of these are pretty obvious. This point, which is 0, 0. So literally, you will not lose money if you do absolutely nothing, according to this. Great, there's plenty of people doing absolutely money, not losing money in their business. Now, they might be starving because they can't buy food, but that is an option for you in this business to not lose money but meet all of these conditions. Anything along here would be great too. But if I want to be the best, it's going to be one of these 4 points where you have intersections. Now the intercepts you've already found, so those shouldn't be that bad. What was this intersection right here? 0, 175. So you've already got that. And what was that intersection right there? It looks like 240, but what was it? 250, 0. This is the only one I'm going to actually have to find here. So how do I find that point where these two graphs intersect? Solve the system. Now you might have to do that a couple times, but most of the time the points are like there, on the intercepts, or maybe 0, 0. there might be one or two you have to find. These were the two graphs that were intersecting, right? So solve that system. Now, I'm not going to take the time to actually solve that system. If it were me, I guess you could multiply through by a negative 250, or maybe you could cancel it, divide by 10 first to kind of shrink these numbers down, make them a little smaller if you were doing it manually. You could do the substitution principle. Now remember, when you're actually finding the intersection, you don't care about the inequality. So you can ignore the inequalities while you solve. Are y'all tracking with me? But substitution, whatever you want, find that x-coordinate, plug the x-coordinate back in, find the y-coordinate, and you end up with the point 200, 50. So, trust me on that. So these 4 points are where any point in this region, including the edges, you would not lose money, okay? But you want to do the best possible situation you can do. And the best ones, or the worst ones, depending on what you're talking about, are going to occur here, 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 or here. But anything outside of here, you're not meeting all of these conditions, right? You might have, more than 250 units, okay, which is great, but like, I'm probably not gonna, this would be great if I did that, but according to my situation, it says I'm not gonna sell more than 250. Maybe there's only 250 people in the town, I don't know, whatever. But I'm not gonna sell more than that. Or I can't invest more than this, this is all the money I have. So based on this model, I'm gonna take these 4 points and I'm gonna plug them in my profit. And I'm gonna see which one spits out the best number for me. So what is P of 0, 0? Well, obviously 45 times 0 plus 50 plus 0 is 0. Not doing super well there, right? At least I didn't lose money. All right, and then what about the profit at 0, 175? Well, that's 0 times 45, but 50 times 175. And that one spits out 87.50. All right, now we're talking. All right, if I can make 87.50 a month, it's roughly 100 grand a year, running a little CD shop, not too bad. In fact, according to this model, if that was the best situation, I don't even have to diversify. I can just buy one kind of CD player and say, hey, I'm better off just selling that one CD player, making 50 bucks a deal. Maybe that's the best situation. I'm gonna go check the next one, or I'm gonna check the other one. P, what about 250 of that one, and none of them. So this is just selling, maybe I'm in a lower income part of town, or I'm in a place where people don't appreciate the quality you get from that more expensive model. Maybe I just go with all cheap model. How much does that make me? Ooh, check it out. 11, I'm gonna be going to, 45 times 250, 11.5. So at this point, this is way better than the other one. So maybe I want to specialize in just the cheap, but more than likely, it's some combination of the two, right? So if I plug in the 200, 50, I'm doing 200 of the 45 and 50 of the 50, and I end up getting, when I multiply those two together, I get 11,250, not 11.5. And then when I do this one, I get 11.5. So it turns out that this guy spent 5 minutes, 10 minutes, whatever, on a little linear programming model and found out that he's better off having a little bit more diverse of a product, having a couple options for his customers, and he can make an extra $250 a month. And he spent $10 of work. And if you had a business, granted, there's more to this, because there's probably marketing surveys, there's probably getting in touch with your community and finding out what kind of demand there is for stuff. There's other things that go in, and maybe you understand that as a member of the community. Like, in Homewood, you can put a really nice restaurant in Homewood because there are people that have money in Homewood that are willing to go do that. And if you travel down 280, the further you get down 280, the less and less nice restaurants you have. I mean, like, is it Chuck's? There's a Chuck's down there on 280. There's a Little Donkey over there on 280, but you go down another 5 or 10 miles and a nice restaurant is like Hardee's. I mean, it's just, you don't see a lot of that because the further you get away, the less people really care for that kind of stuff. So understanding your market and what the market needs is all obviously important, and probably a huge reason why a lot of companies fail, because they don't really understand who they're dealing with. And that's obviously not in this problem. But you can see how I just spent 5 minutes, I just saved $250 a month. If I can spend 5 or 10 minutes and save $250 a month, that's a pretty good deal. I mean, even $250 once for 10 minutes is pretty solid. I don't know about you, but I would take that kind of hourly income all day long. Y'all with me? Okay, let's check out another one. Oh, another thing that you're not going to need to do. But the profit here is kind of like an unknown number, but it is like a number. Okay? It just changes based on X and Y. One thing you could do is solve for Y here. Check it out. If I solve for Y, I get number minus 45x. Let me write it better. I get some number minus 45x divided by 50. Are you gonna follow me? So right here, this would be y equals that. Now, if I clean that up, that gives me y equals negative, what, 9/10 x plus a number over 50. I'm just going to write that down as just some constant. I don't know what it is. If I graph that, I get a sloped line, okay? 9/10 is not quite -1, but it's kind of close. If I take that sloped line, let's just pretend that it's this ruler. This would be 9/10 roughly, right here. If I take that sloped line and bring it down, the first point it hits is where I maximize profit. So had that slope, if I had solved for y and that slope had been something like -1/10, -1/10 would look more like this. If I bring down -1/10, what's the first point it hits? That one. Well, then that would be the point. So you could also do it that way, but I seriously doubt any of you want to actually solve for y and simulate that slope and slide it down to the point when it's pretty easy just to take the points and shove them in there. Okay? Now, with profit and revenue, you would slide down. With cost or expenses, you would slide up. Okay? Because you're trying to minimize cost expensive, maximize revenues and profits. But most people don't think that way. It'd be great if you had some like fluid program and you could just put in this and say, all right, I'm gonna let that slide, and that's kind of like the y-intercept. So I don't know what the y-intercept is, but the slope's always -9/10, and that's would be -9/10 ratio. And you can see that if I bring that down, boom, right there. Now you're gonna notice on these problems, very likely, a lot of the time, it's this. It's why McDonald's doesn't just sell hamburgers, and they have McRib and filet of fish and breakfast. The more they diversify, the more when a family comes in there, everybody's happy, right? I mean, when I was a kid, McDonald's was like just heaven. You were like, I mean, you just wanted to go to McDonald's more than anything on the planet when I was little. And they didn't have a ton of options. But my dad freaking hated McDonald's. So we would go on like these cross-country road trips. Breakfast, lunch, dinner. Hey, what do you want to eat? McDonald's, McDonald's. We want to go, and he would just sit. I remember him just sitting in front of the board going, just shaking his head because all there were hamburgers. And when the filet of fish came out, it was like, he thought it was the greatest thing on earth. And the filet of fish, I mean, it's not that awesome. But it was something different. So if you can bring up something in there, that's why about every place on the planet serves chicken fingers. You know, because kids will always be happy with some chicken fingers, right? Anyway, whatever. So this is showing diversification sometimes makes it a little bit better for you. All right, check out the next one. This one's a little bit weirder in the numbers, but again, if you saw something like this on the test, I think you'd be okay because you'll have seen it before. All right, but use your guidelines to help yourself out, and this is where the units are really going to be important to you. Just really be careful. And I might need to explain this a little bit. So if you're a company and you are, if you're an accounting firm, there's a lot of different things you do. Like you might do people's taxes, and that takes time, right? Like I have an accountant. I bring him all my information from my LLC and little side, my wife's business, and all the stuff we have, and I go, here. And I might do some things to organize the information, to cut down on his time, to lessen my charges. But I bring it to him, and he does my taxes. He spends time doing that. But also one of his jobs that he does, not for me, but other people bring in all their information for their business, and he does auditing work for them. Like he'll go in there and he'll look at all their business, make sure everything's legit, make sure their books are in order. Because if you're like, especially if you're a publicly traded company, if your books are in order, that can be fraudulent, or they can be interpreted as fraud. And especially when you have stockholders that are looking for those books and looking for that financial information, they're making judgments on investing and things like that. So if things are shaky and a little sketchy, that's not good. Well, people go through there and they will audit your numbers and audit your bookkeeping. And sometimes I know Homewood had some auditing issues probably 10, 15 years ago that were really bad. We were actually in a really bad financial position. We've, in the last few years, have pulled out of that. But it was because we had an auditing firm that came in that was terrible. And we had an accountant that was good person, but terrible. And they had made all of these mistakes, and it was millions of dollars of bad debt or whatever it was. It was really a bad situation they put us in. That's when I used to teach 67 kids in 5 classes. That's it. Like my class sizes were 9 and 13. I once had 18 people sign up for this class, pre-cal math team, and they went, oh, that's way too many for one class. We need to split that. 18. And they split it because that's too much for that changed real quickly when you start getting a bad financial situation. All the numbers started rising up to 20, 22, 25, 30, and we're just starting to get in a place now where those numbers are starting to drop. We're starting to get more reasonable numbers in classes. But anyway, point is, there are 2 kind of aspects of accounting that we're talking about here. So the first thing it says, I want to read through there. I read the problem. It talks about a firm has 900 hours of staffing time and 100 hours of reviewing time. So that basically means that's how many employees' hours they have at their disposal. They can't take on more work than that, or they're going to be killing their employees and not making them functional. Although most accountants get killed if you have a parent that's an accountant. Sometimes they vanish for a few months, like especially right near April 15th or during every quarterly. So like I know my accountant just literally, he didn't even go home sometimes. He crashes at his office or because he's working 20 hours a day. And then sometimes he's free and he does hardly anything for a month. But anyway, I've got this. It talks about charging, how much you have audits and tax returns. Talk about how much time it takes for an audit, or how much time I have available for audits, how much time I have available for reviews, how much tax return requires in terms of staff and review time. And the question is, what number of audits and tax returns yield the maximum revenue? So I'm reading through that, and initially it's just blah, 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 blah. So I'm going to have an approach to it, and that is, first thing, what am I even talking about here? So X is what? The number of audits. The number of audits. And Y is the number of tax returns. And all the rest of it was talking about how much time my employees would be spending on each one. So I checked the first box. The second thing is what? Figure out the revenue situation, or profit or cost, whatever it is. This one's revenue. So my revenue that I'm going to earn, this is just money taken in. How much am I making for each audit? $2,000 an audit, $300 a tax return. So $2,000 for each X, $300 for each Y. And I'm done with that and that. I don't want to look at that anymore. Okay? Now, what do you see here? These are audits and tax returns. So I'm going to look through, look for inequalities. Where do you see inequalities?
Time.
Staff time? I only have 900 hours of staff time available. That's it. Do I have to use all of it? Maybe I'd like to, right? Maximize my income. But the most I have is 900. So the staff time, 900, I would have to be less than or equal to that. time, right? And what else? 100 hours of review time. That's all I have available. I could use less than that, but I only have so many employees. They only have so many hours in a day that they can actually be here, less than or equal to 100, and that is review time. Now, clearly, X plus Y is not less than 900. Number of audits, number of tax returns, staff time, that doesn't make sense, does it? The units don't match up when you talk about number of things and then time. So let's take a better look at X and Y. I know that X and Y are going to come into play here, right? I know they're going to be in there somehow, if you kind of want to start like this. But what does it talk about when you start looking at audits? Okay, so it takes 100 hours of staff time and then 10 hours of review time. That's an audit. So if this is X's audits, what do you think is going to happen here? Okay, so I have 100 hours of staff time. So for each audit, 100, and then what? Well, I'm going to stick, well, you can jump to that. If I'm still on staff time, 12 and a half hours of staff time. And time times the number of audits times the number of tax returns, total amount of time. Now, that takes care of the 100 and the 12.5. Now what? 10 hours of review time, right? Review time, 10 hours for each audit is review time. And then what? Each tax return is Y, 2.5 hours of review time. You see how I'm allocating all this? So I'm putting the 100 and the 10 because that's audits. I'm putting the 12.5 and the 2.5 because that's tax returns, but I'm grouping staff time, review time. And I've got two equations. Now what else do you know about X and Y? They gotta be greater than or equal to 0, right? And I'm good to go again. Now, how are you going to label these? It might be a good idea to understand what? Your X and Y intercepts. So, on these, it's a little trickier. What is your, well, maybe not. On your X intercept, right, that's when Y is 0, 900 divided by 100. So I'm going to be pulling off, that's going to be intersecting at 9. And then, so 9, 0. And then the Y, 900 divided by 12.5 is 72. So if I wanted to sketch that, if this is 9 and this is 72, there's a really good chance my X and my Y units are going to be different on this problem. I don't have to make them, I can make them the same, but I believe on this one I made them different. But let's keep going. What is the review time here? What's the X-intercept? 10. And the Y-intercept? Is it 40? 40? So on this particular case, I thought, you know what, since my X values only go to 9 and 10, I'm just going to number these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And since these go to 72 and 40, what do you want to number these? It's got to at least get into 72. Any ideas? You could do 9, 8, or you could just make it a cool 10 and be easier to kind of think. It's up to you, doesn't matter. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. But it's totally up to you how you number them, as long as you can get everything in there. So I'm going to graph this first one. X-intercept of 9. Y-intercept of 72. Second one, X-intercept of 10. Y-intercept of 40. Don't forget this equation. I mean, this X and Y equals 0. they intersect here, right? And if you think about the shading, both of these are shading down. So if this one's shading down and this one's shading down, both of these are shading up, which of course puts you in the first quadrant. And look, there is your feasible region. And like before, you're going to have probably a couple of easy points to find. You already know 0, 0 down here. You found that intercept, that's 0, 40. You found that intercept, that's 9, 0. The only one you really need to work on is that one, and you're going to find that one by solving that system. And for me, I'd probably just multiply the bottom through by a -10, cancel some junk, and be on your way. But what you end up with is 8, 8, which probably doesn't look like 8, 8 on this graph because I didn't graph it perfectly. But are you tracking with me? And then you come back to the revenue equation, and you're going to plug 0, 0, 0, 40, 9, 0, and 8, 8, and you're going to find, typically you will, at 8, 8, you ended up with 18, 4, and the closest thing to that was 9, 0, which gave you 18, and you might go, oh, it's only $400. Well, if I can do 400 each week, right, 52 weeks, that's an extra 20 grand. That's cool by me, and I just spent 10, 15 minutes working this problem. And how come I was only able to do 2 of these, I don't know. Hey, do the best you can on your homework. We still have tomorrow as a review day. We can talk more about these, answer questions, and then we're going to test on Friday. And that's it. All right?